Hello everybody, this is Gianluca and welcome to this new episode of your Data Teacher podcast. Today I'm going to talk about the Quantile Plot, sometimes called QQ plot. This is a very useful plot that is used to see if dataset, a sample dataset, follows a particular distribution. It is useful even for assessing the likelihood of the distributions of two datasets, so in order to try to figure out if they have been created from the same original distribution. The idea is that sometimes a data scientist has to figure out if the data follows a particular distribution or not. Statistically speaking, there is the Kolmogorov-Smirnov test. There is a hypothesis test that can be used to see if a sample has been created according to a particular distribution, but according to my experience, a simple visualization is better than a statistical test that gives us a p-value that must be interpreted. The idea behind the QQ plot is this one. It is a two-dimensional plot. In the x-axis, you set the theoretical quantile of the distribution you want to check, and in the y-axis, you put the sample quantiles. If the sample has been created from that theoretical distribution, we expect that the points lie on a 45-degree line. If the distribution of the sample is different from the theoretical distribution we are checking, the points will not lie on such a line and we will get other shapes of this plot. It is usually a scatter plot, and since the baseline is a 45 degrees line, we usually plot this line as well. So it is very useful to graphically assess if a dataset belongs to a particular distribution. And I usually work with this kind of plot because it is very simple to explain even to non-technical people. One important part of building this plot is to try to fit the best distribution of the kind we are checking to the dataset using, for example, some maximum likelihood properties. The most common use of QQ plot is to check the normality of a dataset. So you take the dataset, you calculate its mean and its standard deviation, you calculate the theoretical normal distribution with that mean and that standard deviation, and you draw the chart just like I have explained before. This is how we can assess the normality of a dataset, but the concept is exactly the same for any other distribution. Not all the distributions have some parameters that are closely related to the mean value and the standard deviation, so you will have to find the best distribution of your kind that fits your data using some maximum likelihood concepts. In Python and in SciPy, all the distributions have a fit method that tries to fit a distribution on a dataset, changing the values of its parameters in order to have the maximum likelihood between the features between the dataset and the distribution. This is a very common approach when you want to check if a dataset belongs to a particular distribution. We usually work with the normal distribution or, for example, other theoretical distributions like the uniform distribution or maybe the log normal distribution. But we can see using this plot if a dataset has been created according to the same distribution of another dataset. We just have to plot the quantiles of both datasets in both axes. So in the x-axis we put the quantiles of the first dataset, in y-axis we put the quantile of the second dataset, and if we get a a set of points that lie on a 45-degree lines, we can say that these two datasets have been created according to the same distribution. In QQ plots, we often have some problems at the extreme values, so the outliers don't always lie on a 45-degree lines. This is a common problem, but it is not a great problem, because we need to check the most probable part of the distribution. The outliers must always be handled with care and with particular techniques. So we don't have to care too much about the outliers. Even if we perform some simulation, we'll always see that the outliers, even for a normal distribution, will show some problems when we plot the QQ plot. But it is not a huge problem. We just have to see if the majority of the points lie on a 45-degree line, and this can help us understand if the data is normally distributed or distributed according to the distribution we want. This is very useful. This is a very nice representation, graphical representation and visualization of a particular phenomenon we want to assess, that is the fact that a dataset has been created according to a particular distribution, or two datasets share the same distribution, the same original distribution. This is a very common visualization, and in data science, particularly in exploratory data analysis, we love data visualization. My suggestion is not to use statistical tests. There are some statistical tests for normality, like for example Shapiro-Wilk. I always think that interpreting p-value is quite difficult, and we always need to visualize our data and the information we want to extract from our data. That is why I prefer using a QQ plot. So thanks for listening to this podcast, and don't forget to visit my website, yourdatateacher.com.